we can train the computer such that the computer can tell us something new. Okay. For example, I want to train the computer to identify new Monte Carlo algorithms for me, and we are still working on it. Okay. So with that, let me conclude. So I take this quote from Charles Dickens' The Tale of Twin Cities. So best of times it was the worst of times. I think that now is the best of time and the worst of times. You can get a big success if you do things right, but it takes a lot. It has a lot of risk, but that's what is exciting. Okay. So finally, I acknowledge my collaborators. So here, listen here, my long-time collaborator, Ko Chung Chen, and I'm recently started with Yu-Xin Lin and Anders Sambich, and a couple of people that was listed in the paper. And recently we started some collaboration with David on some field theory stuff. And also, yeah. So these are the students and postdocs in my group. Okay. And these are the field, the problem, the computational physicists. Okay, so this is our proposal. Thank you.
Okay, the floor is open for questions. Okay.
What is the application for streamions?
What?
What is the application for streamions?
What's the
application?
Application?
Yeah, I mean, because, yeah.
One thing is this.
Like.
Okay, I might not the right person to ask about applications, but from what I read, is this racetrack. I think this is one of the. I think this one is room temperature. Yeah. So I think this is one of the latest type. Okay. But for me, I just do it for fun.
Okay, any more? Have you tried any this CPU or GPU or CPU power provided by commercial companies? Does it, you see all this research, the computation is very important.
Right.
So the computing power essentially is crucial part of this study, right?
Right.
But nowadays there's a lot of commercial, CPU available. So have you ever tried to use them to see the outcome?
You mean just put my calculation on the cloud? Like
yes.
Amazon? Or
yes, Amazon.
I haven't tried this because I don't know how to tell to charge it to my brain.
Oh.
I see. If you know how to do it, then I'll be happy. I mean, I think it's a different aspect. Amazon, they have some computing cloud.
Yes.
They have some GPU instances.
Yes.
But I think they're still thinking in terms of this more like their specs are slightly different from what we mentioned, right? And, but I think that the question is that I don't know how to charge my brain.
Yeah.
But I think they have not been geared towards really heavily parallelized.
Yes.
They're more distributed.
Yes.
So in the past it has not been a good option.
Yes.
Okay.
Yeah, but recently, okay, because of this TensorFlow, so one thing I've been trying to do, but is that because TensorFlow can deploy in Google Cloud easily, and supposedly they have some underlying tensor operations. So I'm still trying to convince my students to write the margin code in TensorFlow and see if it works. But I think there's a different conventions and ambiguities. We were still trying to figure out. So that's why, yeah.
tell.
Yeah, I'm interested in the very last one. The other way around. You see the temperature, right? You see the pattern and predict temperature. And then if you take a look into this network, which part of the network is enhanced? Is there any way you can say that? I mean, basically, if we take a look at, there's no way to say which temperature.
So actually, that's a good question.
Yeah.
So one thing we still haven't figured out is that because now the way we train it, we train it with several layers. So I should be able to see a Boltzmann distribution at some point, but we still couldn't identify it. I mean, there's a distribution for these output neurons, but yeah, it's not clear. So what I show here. Yeah, for example, what kind of distribution is this? It should be a Boltzmann distribution, right? And this is just a tail of the Boltzmann distribution. But we haven't really analyzed this part. That's one thing that we're.
So you think you can figure out?
Yeah, hopefully. But this is just a quick run for the demo purpose. I still want to, so let me see if I can find this. So I don't know if you see this, DeepMind has this Atari. So this is actually very cool. So this is something called reinforcement learning. So basically just teach the algorithm to play Atari. Okay. 就是那个状况。Okay. So this is so basically the algorithm try to hit the ball, but can't really do it. But after, so this is, you don't really tell the machine what to do. Okay, so I think what they did is just put it, try to increase the score. Okay, the rule is increase the score, no matter what. And this is what the machine after 2 hours. And even amazing, so a lot of tricks that only human can do. You learn to do when you were a kid. So this is the most amazing part. So it learns to be the tunnel. So remember when the day that the old days you were playing this, and the machine learned by itself. Okay, very simple rules. And this is I would like to do. I would like machine. I mean what all this is being done is some kind of a classification.
Yeah. I have a question. So the basically, take this game as an example. We are trying to find kind of hidden parameter, right?
Right.
Hidden logics.
Right.
So the quantum mechanics basically doesn't have any hidden parameter. But when you do the statistical mechanics, okay, it seems like you have something that.
Yes.
Right?
That's there's an underlying.
Yeah.
One thing we were trying to do is that in our simulations, it's important to Monte Carlo with large clusters, but it's almost case by case that a human has to come up with a new algorithm, and this is the best way to do it. So we're trying to train the neurons, see if they can pick up some of these clusters using just this reinforcement learning. Okay, got it.
But this algorithm is not unique, right? So you just pick up the random some available in the market. When you when you say training, train the.
So basically, you build a neuron, and
Yes.
there's different models. So these models are, I mean, the more successful are so-called supervised learning. So basically, you give a lot of data, and there's labels, and you just teach sort of train the neuron. Say, okay, I know this is a cat. Okay, this is a cat, and after tons of data, then the machine will, if you feed it a cat, you'll identify. You'll learn the characters.
Yes, but I thought there are many algorithms available.
Yes, and so yeah. So this is I think this is recently because of this AlphaGo thing that people start getting interested in. But I think the future is still this. It should learn. I just set very simple rules. Okay, this is what I want. Find this for me. Otherwise, I won't be worried that AI is gonna.
That is mathematics. Mathematicians should devote their effort on this. Okay, any other questions? If not, let's send Professor Gao again. 事实上，我